There we go. Okay, so here we're learning some more complex rules of integration. You can think the title is called Integrating f of ax plus b. And so what is that? It's a composite function, right? It's a function composed of a line, some linear. So as the examples pop up, I'm just going to jot the rule alongside. And I love rules, I'm sure you guys do too, you're in year 12 mathematics. And so all you're doing is, here's the statement, and we're just substituting accordingly to solve it. So here we have the integral of 2x take 3 to the power of 5. So you can see we have ax plus b to the power of n. This is the one it resembles, okay? It's some linear function to the power of n, something we would use the chain rule for differentiation. So this is the rule for integration. So this is going to become 1 on ax plus b to the power of n plus 1. Alright, so 1 on a, and then we just have the function to the power of n plus 1, 5 plus 1, on top of 5 plus 1, plus c. That is it, okay? Can simplify a bit. At the bottom we're going to have there 6, and 2 times 6 is 12, so you can think about it as 1 on 12, 2x take 3 to the power of 6, plus c. That's a. Here we go for the okay, sine of ax plus b, I'll write the rule here. Alright, so we've got a 3 out the front. The first thing is that the 3 is multiplying it, the 3 is just going to stay there. We could pull it out the front of the integral if you want to, but that's just going to hang out because it's times it. Okay. Then we go the integral of sine of ax plus b. So we've got to identify what's the a value. The a value is always the coefficient of x. So the number in front of x is minus 2. We must include the negative. So we have minus 1 on a, which means we have minus 1 on top of. The a value is minus 2. Okay, so we've identified the coefficient of x, and we're putting that there. That negative staying there, minus 1 on top of a, and then we just have cos of exactly what we have there. We don't need to change it. The ax and the b, close the bracket, plus c, and we can simplify. The negative and the negative are going to make a positive, so we have 3 on 2, cos of 5 take 2x, plus c. Okay. C, we have the integral of 0.5 e to the 7x take away 1 with regards to x. Okay, so the integral of e to the ax plus b is 1 on a e to the ax plus b plus c. So again, 0.5 times, that's just going to hang out front. That stays there. Integral of e to the 7x take 1. E to the ax plus b becomes 1 on a, e to the ax plus b. So again, identifying the coefficient of x, it's 1 on top of the coefficient of x, e to the ax plus b. And then plus c. So that was c. Okay, and d, we have the integral of 1 on 3x plus 2 with regards to x. Okay, so this rule here is written outside the box. And the reason that's the case is because this did not used to be part of the course. They changed it in 2022. All right, so this rule is now part of the course, but it's not in the textbook. Okay, so just over the page, I've got 5 questions for you to do there that detail that rule in specific, okay, in particular. So let's go over it. We have 1 on ax plus b. The integral is 1 on a ln of ax plus b. plus c. Okay. Now this is only true provided 3x plus 2 is greater than 0, provided the inside component is positive. So, not that we need to write that caveat, but this is true because ln of x exists as long as x is greater than 0. Alright? Good. Okay, so that's enough to rip into 4f. We're just applying the rules. We'll get some more complex integrals. Let's do it. Friday afternoon.